Hello, welcome back to another episode of chemistry. And in this video, we're going to be talking about toxic substances and the research that you will have to do and how you can do that for this assignment that's due at the end of Wednesday. So basically, you're going to be picking out a toxic substance, and really it can be any substance, right? Because anything in the right amount of dosage can be toxic. But there is a list of kind of more popular toxic substances that you can find on Canvas. And so I'm just going to run through an example of my own. And so since I'm on my 54th cup of coffee, I thought a good one for me to go through would be caffeine, right? I've had so many coffees I can actually see the molecules just kind of floating around. So what we're going to do is we're going to jump into notability here and basically see what we have to do. All right, so you got to get your notability ready. And then here we go. Okay, so now that we are inside the iPad, we can take a look at caffeine and kind of run through the items real quick, and I'll show you how or what I'm exactly looking for each one. So I just included the list of things you have to do for your research, and we'll just kind of go through this one by one. So the first few are all kind of straightforward. So what is the chemical formula? Include a structural picture. So we can look at caffeine, and I just found this online, and you can just kind of see. All right, so the chemical formula, this guy right here. And then our structural formula is what the molecule actually looks like on the atomic scale. So how the molecules or what elements are bonding to what other elements, right? What objects or substances commonly found in include a picture of one said object. So caffeine is commonly found in coffee and things like that. It's derived from cocoa beans in South America mainly. So I just included a picture of cocoa beans. That would be fine. What is the lethal dose? Remember, that's going to be something you can look up fairly easily, and the units for lethal dose is milligrams over kilograms. Right? We call that the LD50. Right? Because it takes how many milligrams to kill 1 kilogram of an organism. Okay. So the next few are all dealing with bonding. Now, you don't have to do all of these. It depends on what substance you pick and what type of bonds form your substance. So we really have to take a look at this first question, or of the next set of bullet points. Is the bonding in your substance ionic, covalent, or metallic? Hopefully by now you know the differences between the three, right? Ionic, just to review real quick, ionic is metal plus non-metal. Covalent is when you have multiple non-metals, right? They're sharing electrons. And metallic is just between other metals, right? So that's one's fairly intuitive, right? And so you have to look at the structural formula of your substance and determine is it ionic, covalent, or metallic. Caffeine, for instance, if we look at the structural formula or the chemical formula, we can see that all of these are non-metals. So this has to be a covalent bond or covalent molecule. So that means I'm just going to, of the three we see here, 1, 2, 3, I just have to do this one, right? Because the other one's ionic and the third one down is metallic. Okay. And this is the one I kind of wanted to talk about the most because this one is talking about dipoles or dipole-dipole interactions. So if your substance is covalent, determine if it is polar or non-polar. Explain your reasoning. Include the structural formula and show the dipoles. So the dipoles, what that means is within a polar molecule, we have parts of the molecule that are positive and parts of the molecule that are negative. Right? Our common example is water, right, which is a polar molecule. It is negative on the oxygen side and positive on the hydrogen side. So when we say the dipole-dipole interactions, you have to draw this is the delta symbol, kind of looks like a music note or a D with a slight hook. And you just have to show the positive and negative parts and where they're found in the molecule. Okay, so for caffeine, and this is really true for most polar molecules, and caffeine is a polar molecule, the electrons are going to move towards the oxygen, move towards the nitrogen, and move away from carbon and hydrogen generally. So you definitely want to look this up. You don't want to just kind of like take a guess at it. Okay, this is research, right? So, but I just know in caffeine, we have negative parts by the hydrogens and the nitrogens. So I'm just going to go ahead and draw these partial negative charges, these delta negative charges, and I'll just highlight them for you. And basically, that means that those electrons, the electrons in the molecule, are moving towards those elements. And so if we think about CH3 right here, we have an electron and it's moving towards nitrogen. So that means that CH3 is going to be partial positive, right? Because now it has lost part of its electron. When they're sharing it, nitrogen just shares a little bit more of it, right? So that's how it gets that negative charge, because it has more of the electron on its side. And that's going to also be true here, 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 and here. Right, so we have included all of the charges found throughout the molecule. Okay, so determine if it's polar or nonpolar, and then if it is polar, it's going to have those dipole interactions, and that's what you see here with those partial charges. Just to step back for a second, if your substance is ionic, determine the cation and the anion. Right, so just look at this one real quick. That one, remember, a cation is just a positively charged ion, right? So if we're thinking of cats, a cation is positive. Oops, positive ion. Anion, we can think of an onion. Onions make you sad or make you cry. They are negatively charged ions. And then if your substance is metallic, for the last one, if you have a metallic toxic substance, find out its density, include a particle view drawing of your substance. And so for that, we have, these are just kind of 3 examples of particle views. You just want to show if you have a really dense toxic substance, you're going to want to draw something similar to this solid. If you have a gas substance, it's going to look something more like that. But just basically, if we could scale or zoom in, what would those particles be doing? Are they really close together? Are they bouncing around? Are they extremely dense, or are they not as dense? That's what you have to find out. And then the last one, does your substance conduct electricity? Explain your reasoning. So remember, we talked about electricity, and basically things with multiple charges, or things with charges, a positive charge and a negative charge, are going to be able to conduct electricity, right? Because those electrons are going to pass or flow the electrical movement, creating a current. So any polar molecules are going to conduct electricity. Any ionic substances are going to conduct electricity, as well as metallic substances. Okay, and if you're not sure about yours, this is research. Look it up and make sure you have a valid source. And if you're still not sure, just send me an email and I'll be sure to take a look at it. All right, that's it for the toxic substance research video. Let me know if you have questions.